Hello, we're going to try and put together a quick little video on how to solve rational equations. Rational equations include any equations that deal with fractions, especially where there are variables in the denominators. We're going to really stay away from proportions, two equal fractions in this video. We're going to look at things that have more than just those two fractions and how that will play out. As we start solving rational equations, the first thing you want to do is identify what that common denominator is going to be. It's helpful to find the least common denominator. It just saves you work later on. Once you know what that common denominator is, you want to multiply both sides of the equation. That means each term in that equation by that common denominator. When doing that, what you should do is cancel out all your denominators somewhere along the way. Be careful to distribute as you multiply when needed. Now, you're going to get a new equation. It's not a new equation with new values or anything like that. It's not going to change the value of x. It's not going to do anything like that. However, it will be something that no longer has x's in denominators, probably anything else in a denominator for that matter. However, since you multiplied by x's, it's possible that you've created what are called extraneous solutions. In other words, things that at the end of your solving process look like solutions but really aren't. All right, as we take a look at this particular problem, we're going to try and look for our least common denominator. Our least common denominator, first thing I'm going to do is factor this over here. I'm looking for two things that multiply to 42 and add to negative 13, and they are actually going to be x minus 6 and x minus 7, which coincidentally are the same factors that we have showing up there. So if we look at the least common denominator, okay, least common denominator, I'm not a big fan of the acronym, but let's use it for space's sake. We're going to need an x minus 7 in our least common denominator. We're going to need an x minus 6 in our least common denominator, and we're going to need an x minus 6 and an x minus 7. Well, we already have those, so we don't need anything else. So this is what we're going to multiply both sides by. We're going to multiply this piece over here by x minus 6 and by x minus 7, and when we do that, these are going to cancel out very nicely, very beautifully, and we're going to be left with just this 13 over there on that right side. Now, on the other side, we are going to multiply both pieces. Well, let's just do the whole side first. Let's just think the whole side. We're going to multiply the whole side by x minus 6 and by x minus 7. Now, technically, these are over 1. We could have said the same thing over there. And if I'm doing this here, we have a two-piece thing. So I'm going to distribute it to take all of this and distribute it in here and in over here as well. Now, what does that mean? We're going to get, let's see if we can just squeeze it in here, an x minus 6 and in x minus 7 also on this piece. So we'll try and change up the color a little bit so we can see what's going on here. Over here, this x minus 7 is going to cancel. We're going to have this 9 and this x minus 6 left. So we'll have 9 times an x minus 6. Meanwhile, in here, we're going to have the 7 and the x minus 7. Now those are all multiplied together. There's the x minus 6 is canceling out. So we'll have a minus a 7 times an x minus 7. And there's our equation now. So now that that's our equation, let's go on and finish solving this. Let's make sure we distribute our 9x minus our 54, subtract a 7x, and add a 49. Make sure you distribute your negative sign. And now you can see we've got a nice little equation that has no more fractions in it. All right, 9 minus 7 is 2x, negative 54 plus 49 is negative 5, and we should be in a spot where we can see that this is a doable equation now. All right, just a little divide by 2 on both sides, and we'll get x equal to 9. Now, if you remember, our last step was to check it. Check it. Check to make sure it wasn't an extraneous solution. Well, our extraneous solutions would have come from this least common denominator, or really any of the denominators that we had seen along the way. It would have said, well, hey, x minus 7 cannot be 0, and x minus 6 cannot be 0. In other words, what we're saying is x cannot equal 7, and x cannot equal 6. Well, this is not sorry about that, this, try that one more time, sorry about that, that is not a 7 and it's not a 6. So it is our solution. There we go, x equals 9, it works. And we could plug it in and check and make sure that it worked, it would work just fine. Let's take a look at this one also. All right, so if we look at our least common denominator again, really we'll make the 4 into a fraction real quick. And it's already factored, everything in the denominators is at least. So we'll take a look at this b plus 1, 1, well everything has a 1, and a b minus 1. So our least common denominator, or our common denominator, is going to have those pieces. It's going to have a b plus 1, and it's going to have a b minus 1. So we're simply going to multiply both sides by that b plus 1 and b minus 1. All right, and we'll do it the same way we did last time. We'll take this, we'll go b minus 1, we'll go b plus 1. We'll make sure we understand that we're multiplying by that as a numerator, and that's going to cancel off there and leave us with a b minus 1 and a 3b minus 2. That's what we have left on our left side. Now, on the right side, we're going to take our b minus 1 and our b plus 1, and we're going to distribute it. So when we distribute it, the 4 is going to get multiplied by both of them, b minus 1 and by b plus 1. And the other fraction, the b minus 1s, will cancel, and we'll be left with a b plus 2 and a b plus 1. Now, right now it looks like a lot of stuff, but you got to realize we are out of fraction mode. We just have to do some distribution. We've got to make sure that we are careful with this negative sign right here, that it gets distributed in, and we should be in fairly good shape. Let's see what we got. I think we have, oops, let's get back to a pen here. I think we have a 3b squared. We'll have minus 2b, and minus a 3b is a minus a 5b plus a 2. And over here we're going to have 4. Now let's just do this one step at a time. This will be a b squared minus 1 when we FOIL it. Somebody will recognize it as a difference of squares. And a minus. And I'm going to put this in parentheses still, because remember, we need to distribute that negative sign. So we'll have a b squared plus a 3b plus a 2. All right. Now let's take it to the next step. Let's start distributing this 4 and this negative here. So we'll leave our 3b squared minus 5b plus 2 alone for right now. We'll get a 4b squared minus a 4 minus a b squared minus a 3b and minus a 2. A lot of stuff, but let's just start putting together some like terms. We've got a b squared, a 4b squared minus a b squared is a 3b squared. We've got the 3b by itself, and we have a minus 6. Meanwhile, the other side we're just going to leave alone for right now. We'll start getting rid of some things in a second here. Like, for instance, that 3b squared. Hey, we got a 3b squared on both sides. Let's cancel it out. And by cancel it out, technically what I mean is subtract 3b squared from both sides. Okay, next thing I'm going to do is I'm going to add 5b to both sides. Now, some people like to keep all their variables on the left. I like to keep my variables positive. Just a personal preference. I just like it better that way. So that's what I'm going to do. And we'll add the 6 to the other side. So we have an 8 is a 2b, and then b becomes a 4, and there's our solution. Check it. Is it one of the extraneous guys? Is it a 1 or a negative 1? Because that's what caused a problem in this case. It is not. There's my answer, and I can plug it back in to make sure that it works. I hope this helps you with your understanding of how to solve rational equations. Thank you.